Hi students, I'm your Komali Mam. In this session, I came with another excellent concept, that is elimination reactions. Usually elimination reactions students feel difficulty because of how to write the products, what is from where I should remove this, where in this session, your Komali Mam is going to tell you excellent tips and techniques. Few points I'll give you, top 6 points I'll give you. If you know these 6 points, you will solve the questions. Within a first 1 to 10 minutes itself, you will get the clarity. After that, I'll solve some more questions. Then you will get full crystal clear clarity. Let us see what are elimination reactions. Are you ready? In this session, whatever the questions I am going to discuss, those questions, PDF, if you want that PDF, 2 things you have to do, then only I'll give you the PDF. First thing is subscribe to Komali Mam channel. Second thing is give like to this video, and then you send these two, subscribed and like to my WhatsApp number 9110662880. Then I'll give you the PDF of entire questions, whatever I'm discussing, and some more homework questions I'll give you so that you can practice. Let me explain you. Please subscribe, okay? I should reach 1 million subscribers. Will you know? Let me explain you. Elimination reactions. Elimination reactions. Easy, very, very easy. Typical topic, easy way I'll teach you. Right? See, elimination reactions means name itself telling you have to eliminate. What you have to eliminate? For example, see here. From here I am going to remove one halogen. From here I am going to remove one hydrogen. Both are adjacent positions. And in that place, I am going to put a double bond like this. So one halogen, one hydrogen, and I am removing and I am keeping a double bond. That's it. These are called as elimination reactions. Halogen connected carbon is called alpha. That next carbon is beta. See here. This is alpha. Next is beta. That's why these elimination reactions are also known as alpha beta elimination reactions, are simply, we can say, beta elimination reactions because we are removing the beta hydrogen. And elimination reactions are classified into 3 categories. Elimination reactions, how many categories? 3 categories. What are those? E1, unimolecular elimination reactions. E2, bimolecular elimination reactions. E1CB, unimolecular conjugate base elimination reactions. So E1, E2, E1CB, in everything, one halogen, one hydrogen, or one hydrogen, one halogen from adjacent positions we are going to remove. That's it. Halogen, hydrogen, halogen, hydrogen. That's it. But how we are removing, based on that, these are classified. In this session, your Komali Mam is going to teach you E2 reactions, bimolecular elimination reactions. Watch this video up to the end. By the end of this session, that's it. You will get that full capacity to solve the questions. Then whenever you are coaching or your school or your college, when you are doing a self-study, practicing, you see these questions, you feel, wow. Thank you so much, Komali Mam. I am done with this particular topic, you say. Let me begin the session. E2 elimination reactions. What are these? What is this E2 elimination? See what I told you, remove one halogen, one hydrogen. Key points I am going to tell you. Key points. Which points? Key points. Means most important points you have to keep in mind while solving the question. Strong bases are needed to do this reaction. What are those strong bases? Carbene anions, amide groups like this, alkoxide ions and hydroxide ions. When you see this on arrow heating, then it comes under what? It comes under elimination reactions. Mostly you will see in your exam like this: alcoholic KOH or alcoholic NaOH. Actually what happens is, this alcoholic means alcohol plus KOH. So remove this OH, remove this H. Remove this OH and remove this H. So what is your product? Tell me. ROK. ROK in the nothing but alkoxide. You will be getting ROK means potassium alkoxide. Same way alcoholic. Alcoholic. So alcohol plus NaOH. Following. This is OH, this is H. Both you remove, what you will be getting? Sodium alkoxide. These are the good bases. So when you see these good bases upon heating symbol, that this they'll give you, then sodium ethoxidine is there. Ethoxidine. It is a good nucleophile also. Here I am not teaching what is a nucleophile, what is a base. No. It is a good base also. When you see this and delta symbol is there on arrow, then it is E2 reaction. In such a way you all should identify. Key point number 2. It involves anti-periplanar mechanism. Write in your books. What is that mechanism? Tell me. Come on, repeat one more time. If I say repeat means you have to repeat. Okay. What is that? Anti-periplanar mechanism. What is the meaning of anti-periplanar? Whatever the group you are removing, one hydrogen, one halogen, both should be in opposite directions. Halogen, if it is in down direction, hydrogen should be top direction. Both should be in a different directions. Then only reaction is possible. Okay. For example, here I am writing. See, here hydrogen is there and here one halogen is there. So base comes, base abstracts this proton, these two electrons shifts here, it goes here. So here hydrogen is downward and halogen is topward, both are in opposite direction, then only reaction is possible. Are you understanding? So here I am getting RCH double bond CH2, this is my product. This is called as both should be in opposite direction, then only it is possible, otherwise reaction is not possible. Reactant in which halogen is in one side, a hydrogen is in opposite side, then only reactant gives this. These reactions are called as stereospecific. Means specific, that particular reactant only involves in a reaction. Specific means specificity belongs to reactant. Okay, stereospecific these are. Point number 3. Here rate is, I wrote one reaction here. On alkyl halide, this base is attacking. So, rate of the reaction depends upon alkyl halide as well as the base. On these two factors, rate depends. Okay. So, remove this proportionality, put one constant here. So, rate depends upon these two, which means that bimolecular. Tell me students, what is this? Bimolecular. What is the order? What is the order? Order of the reaction is 2. That's why we write like this. Bimolecular elimination reactions. They will ask you reactivity of alkyl halide. Which alkyl halide involves this reaction faster? Tertiary greater than, secondary greater than primary. What is the tertiary? Alkyl halide connected to, see this carbon. Alkyl halide connected carbon. It is connected to how many? 1, 2, 3. So it is tertiary. If suppose alkyl halide connected carbon connected to 2 other carbons, then it is secondary. Alkyl halide, this carbon connected to one carbon or no other carbon also, it is primary. So primary, tertiary, secondary, primary, which is more reactive? Tell me, tertiary is more reactive. Okay. And coming to the alkyl halides, suppose same degree is there, but which iode, here iodide is there, here bromide is there, here chloride is there, here fluoride is there. Which is more reactive? Tell me. Iodide one is more reactive. This is point number 3. Total how many points I told you? I will tell you, I told 6 points. 3 points over. Point number 4. It follows Say-Jeff's rule. Say-Jeff's rule, which is also known as JEE's rule. Here I am not going to discuss the rule, but in short, simple way, I'll tell you. That is, more crowded alkene, more crowded alkene is major. More, I'll tell you what is this more crowded alkene. This is when you take small base like methoxide, ethoxide, examples. See, methoxide, OME, or ethoxide like this. ET means ethyl, ethox, these are small bases. But if you take large bases like tertiary butoxide like this, that time less crowded alkene, less crowded alkene is major. Understanding? Now let us see the next one. We'll discuss about this. Point number 5. Take a screenshot if you want this. Okay? Now let us see point number 5. Polar aprotic solvents. What are polar aprotic? What is a solvent? What are the types of solvents? Polar aprotic. Another part I'll discuss. Okay, here simply polar aprotic solvents. Example I am teaching you. Acetone, dimethyl sulfoxide. These are polar aprotic. When you see these solvents, then you have to identify, okay, this is an E2 reaction. Okay, next one, last point. Regioselective. That's it. If you know this 6 points, see how easily you will solve. Regioselective, stereoselective, come on, right? Stereoselective, stereospecific. What do you mean by stereospecific? As I told you, for example, one cyclic ring is there like this. On this, one bromine is towards you. This bond indicates towards you. Then adjacent hydrogen should be away from you. The dash line indicates away from the viewer. That solid line indicates towards the viewer. Suppose one is towards the viewer, other one is away from the viewer. Then only this reaction is possible. Otherwise, it is not possible. Okay, crystal clear. So in this case, this for example, same another question is given to you. Halogen also towards you, hydrogen also towards you. Then in this case, for example, I am talking about here, there is no reaction. Here, there is no heat. Here I am not talking, just I am talking in this part, no reaction. So we can say specific means with respect to reactant. Out of these particular two reactants, just normal example I have given you. With respect to reactant, they are not, one reactant is not involving, one is involving, then we call it as stereospecific. Okay. And coming to this, you see, 1, 2, 3, suppose I got one butene as product after elimination. One more product after elimination. This is 1 butene, this is 2 butene, 2 products following 1 butene, 2 butene. Okay. Now, out of these 2 products, here position is at first position, here it is at second position. Now, these 2 are structural isomers, position only different, so positional isomers. These are formed in different ratios. So, for example, this is major, this is minor. Means one product is forming major, one is minor. Selective word is with respect to product. One product is major and one product is major, one is minor. Both are structural isomers. In certain region, it is showing variation. Then we call it as regioselective. Bimolecular elimination reactions are regioselective. And stereoselective. What do you meaning of stereoselective? For example, you see 2 butene. 2 two butene, cis and trans, two structures are possible. So these two are stereoisomers. Out of these two, for example, one is major, other one is minor, then we call it as stereoselective. So total 6 key points done. With this, you are going to solve the questions. If you don't know also, I'll make you to solve the question. What is the first point? You have to identify the base like ethoxide, methoxide, butoxide, like that. Second one is like alcoholic KOH, heating. These things you should identify an arrow. And the second thing is anti-periplanar. Means one is towards the viewer, halogen, then hydrogen should be away from the viewer. Then only it is possible. Then the third condition, order. Tertiary alkyl halides faster than secondary, faster than the primary. Alkyl iodides are faster than alkyl bromides, faster than alkyl chlorides, faster than alkyl fluorides. Okay. Next point number 4. Say-Jeff's rule. Which rule? Say-Jeff's rule. So Say-Jeff's rule, what I want to tell you is, out of two, more crowded alkene is more stable. This is when you take a small base. If you take a bulkier base, then less crowded alkene is more stable. This is Halfman's product we say, but here is not that concept. So I am not going to talk more about that. Let us see the next 5th point. Polar aprotic solvents favors this reaction. Point number 6, stereoselective, stereospecific, regioselective. Okay, now let me explain you. Let us see the questions. How easily you solve, you see students. Halogen connected carbon. Check it out, tell me. Halogen connected carbon connected with only one carbon, primary. Halogen connected carbon connected with two others, so secondary. Which is more reactive? Secondary, more reactive. Bromine is there, chlorine is there. Which is more reactive? Bromine. See the next one. Halogen connected carbon connected with 1, 2, 3. Tertiary. Halogen connected carbon is connected with 1, 2. Secondary. Which is more reactive towards elimination reactions? Bimolecular elimination reaction, can you tell me? This one. Second, tertiary. See here, halogen connected carbon connected with only one. Halogen connected carbon connected with 1, 2, 3, which is more reactive towards E2 reactions. That's, see how fast you are doing. Halogen connected carbon 1, 2. 2 carbon, secondary. Halogen connected carbon 1, 2, 3 carbon. So it is tertiary, which is faster. Second one. See the next one. Halogen connected carbon connected with 1, 2. Halogen connected carbon 1, 2. Both are secondary. Then how to solve the question? Let us see. Remove this Br, remove this hydrogen, put a bond. Now in this case, remove this Br, next one hydrogen, put a bond. In this case, pi, sigma, pi. Conjugated diene right there. Conjugated diene is possible. That's why this is more reactive, because conjugated dienes are more stable. See the next question. Here, in this two, which is more reactive, they're asking what I told you. One halogen towards the viewer, hydrogen is away from the viewer. See, this halogen is towards the viewer, then here adjacent. Here D is towards the viewer, means that hidden hydrogen will be away from the viewer here. Ma'am, how you are telling their hydrogen is present? Because carbon valency is 4. So here carbon 1, 2, 3 bonds is there, means one more hydrogen is present which is hiding. Okay. So now this is towards the viewer, this is away from the viewer. That solid line towards the dashed line away. Remove it. Write the product like this. But in this case, you see, this bromine is towards the viewer. Here, deuterium is away means this hydrogen, hidden hydrogen is towards. So, both are towards only. So, no reaction. This is undergoing reaction, this is not undergoing. This is undergoing reaction, this is not undergoing reaction. Out of two reactants, only one reactant undergoing reaction, one is not undergoing reaction, which means that these reactions are stereospecific. Means specificity word relates to the reactant. Out of two, only one is reacting. So this is reacting, this is no reaction. Okay, these are what? Stereo. This is a best example to explain stereospecificity. E2 reactions are stereospecific. Important point. And now, halogen connected carbon is connected to only one primary. It is connected to two secondary, which is more reactive. Come on, see how fast you can do this. Very good. See this one, halogen connected carbon 1, 2, 3. Halogen connected carbon connected 1, 2, 3. But here no alpha hydrogens. So no elimination only. No halogen connected carbon, next carbon is beta. Beta should be there. Here it is not having, so no reaction. Here tertiary, it is tertiary, faster reaction. Next question, halogen connected carbon 1, 2, 3. So it is tertiary, and here only one carbon primary. So which reacts faster? Tertiary. See the next one, halogen connected carbon 1, 2. Secondary. Here also secondary. So when both degrees are same, how you have to solve the question? When both degrees are same, you have to solve the question based upon see the adjacent carbon. In this case, the adjacent carbon is, suppose this is an adjacent carbon, let's say beta. Next carbon adjacent beta. Out of these two, this is let's say beta 1, this is a beta 2. Okay. Technique to write CHF's product is, out of these two, which beta carbon has less number of hydrogens, remove that hydrogen. So what you have to remove, students? This hydrogen, this Br. So CH3, CH3, double bond CH, CH2, CH3. So again, here you see, here this is let's say beta 1. Let's say beta 2, adjacent. Only adjacent you should consider. This side 3 is there, this side 2 is there. From where you have to remove, I told you what is the technique? Less number of beta hydrogens, that side you remove and write the product. So, CH3, CH3. So, I am writing here, removing and writing the product, check it out. In this two, again comparison, which is major. What CHF says is, more crowded alkene is more stable. So put that alkene in the double bond, just count the alpha hydrogens. How many? 3 plus 3, 6 plus 2, 8. Here 3, here 1. Just direct connectivity only you should check. 4. Here 8 alpha hydrogens, here 4 alpha hydrogens. So which is more stable? Can you tell me? Which is more stable? This is more stable. So more stable alkene is major. This reaction is faster. Now see the next one. See the next one. Both are secondary only, you check. Both are secondary only because degree is the same. Connectivity is same. Click on pass and you do it if you want. You know, I'll send you the PDF. Na? Take that PDF later and do one more time practice. Understand. What you have to do is, in this case, remove the Br, remove the adjacent hydrogen and check it out. How to check this? How to check this? Come on students, write. This bond I removed, Br I removed, from adjacent position I remove one hydrogen. So I'll put a double bond. See in this case what I am going to do. I am going to remove this Br and adjacent position. See this H and this Br I am going to remove. So I kept a double bond. Now this pi, sigma, pi both are in conjugation. Pi, sigma, pi. Repeat, what is that? Pi, sigma, pi is in conjugation. So more is the conjugation, more is the stability. So which one involves in a reaction faster? Structure 2 involves reaction faster. See the next question. Which of the following is most reactive towards E2 reaction? So what is the order I told you? tertiary greater than, secondary greater than, primary. So in these 4 options, which is a tertiary? Option number 1 is a tertiary. Next question I am moving. See, this is a concept of dehalogenation. I did not teach you dehalogenation. Now I am going to teach you dehalogenation. Check it out. Dehalogenation means removal of 2 halogens at a time. We call it as dehalogenation. See, before what I discussed is dehydrohalogenation. The meaning of dehydrohalogenation is one halogen at adjacent positions we are removing, then we call it as dehydrogenation. But now dehalogenation, 2 hydrogens at a time I am going to remove, that is called as dehalogenation. So remove these 2, put a double bond. Remove these 2 which are in parallel side. You know, one time I will teach you the mechanism which is not needed. Simply I am going to teach you one time. So first base comes, base A abstracts this halogen, this 2 electron shifts here, this X goes out. That is, you know, anti-periplanar. One is down, one is top direction it is. So both are in different directions, opposite directions. Are you following? This is here acetone is just useful to dissolve the sodium iodide, that's it. We can take sodium iodide in acetone or we can also take zinc in heating. Now let us see the simply remove one halogen, put a double bond. Observe the reagents. Observe the reagent. Observe one more time. Sodium iodide dissolved in acetone upon heating or zinc upon heating. See the next question. They are asking us to write the major and minor products. Till now, I told you a concept that Sage's rule means out of 2 halogen, take that halogen connected carbon, adjacent carbon is beta. Out of these 2 betas, I told you to remove which is having less carbons. But here let us see what is the next case. Here halogen connected carbon, next here one hydrogen, here 2 hydrogens. So first what you should do, wherever less hydrogen is there, you remove and check it out. See the next one, which is having more alpha hydrogen, no beta hydrogen. Remove that and write the product. Just removing only. H and Br or H and high, you should remove and check. See here, what we think beta less hydrogen is having, that is a major, no, but no. Here benzene ring is there. In this case, benzene ring is in conjugation with this pi bond. Means this pi bond is in conjugation with this pi adjacent. So this is major. So in this 2, this is major. I mean, this is major. More amounts we get this product. This is minor. This is minor. Both differs in the position of a double bond. That's it. 2 structural isomers which differs in the position of the double bond. Then these 2 are the examples of regioselective. Selectivity word refers to the products. Out of the 2 products, one product is major, another product is minor. Let us see the next question. This is a small base. This is a bulkier base. Identify. In this case, CH3 is hiding 3 hydrogens. Here only 2 hydrogens. What I told you, less number of hydrogens, less number of hydrogens side you should remove. Okay, this is major. More number of hydrogens, top CH3 is there, you remove it. This is major when bulkier base is there. So let us see, double bond is connected with 2 alpha hydrogens, 2 alpha hydrogens, 3. 3 plus 2, 5, 5 plus 2, 7. 7 alpha hydrogens. How to count alpha hydrogens? Carbon valency is 4. So only one bond is there, means 3 hydrogens are hiding. Carbon valence is 4. Here 2 bonds is there, means 4 minus 2 is 2. 2 hydrogens are hiding. Now put this one in bracket like this, one rectangle. Here 2 plus 2, 4 alpha hydrogens. So more hydrogens, actually that is only major. But when bulkier base if you take, less alpha hydrogens becomes major. This is called Halfman's product. This is called as Say-Jeff's product. This is another concept actually. Okay. Now see question number 17. Observe this question carefully. Here the chlorine is present away from the viewer. So how hydrogen should be present? Hydrogen should be present towards the viewer. Then only reaction is possible. Okay. Now let us write the product. Come on everybody. Same write as it is. Observe this. This is away from the viewer, dash line. Here C6H5 is dash line, means hydrogen, hidden hydrogen. How you come to know hydrogen is hidden there? Because this carbon is surrounded by 3 bonds. Actually total 4 bonds. Out of 4, 3 are only present, means 1 hydrogen is hiding. Then this hydrogen you remove, this chlorine you remove, then only C6H5 is left. This is major. Why this is major? Why this is major? Tell me. Here benzene ring is in conjugation. Okay. Now write the minor product. You should check benzene ring is there. See this chlorine, this hydrogen I am removing, because there are 2 possibilities. Either you can remove 2 different carbons is there, you can remove. Done. This is this is minor. Next question. Question number 18. Check it out, this question. Sodium ethoxide you are heating, means which we are getting ethoxide. Sorry, methoxide you are getting, which is an strong base. What base function? Halogen connected carbon. Next hydrogen. See, let's say this is beta 1. This carbon is there, no? This is this side beta 1. This and this are same. Now let's say this is beta 2. These two are same. Any side you remove it is enough, students. Any side you remove it's enough. They're asking, more stable major product. They're asking how can you find the major product? You can find the major product like that beta hydrogen, that carbon should have less number of beta hydrogens. That is the easy way. So it is having less number of beta hydrogens. Which one? Beta 1. So remove beta 1 product. You write CH3 as it is. Okay. Next question. Try question number 19. Major and minor. Question number 20 also major and minor. Okay. Try these two and you send me this. I'll send you the answers for these two also. The entire questions whatever I discussed with you, and these two, and another, see this question. Take screenshot of this and this also. 22. Okay, these questions, if you want a PDF, I will share with you. I'll give my contact number in the description. Just subscribe Komali Mam channel, give a like to this video, and then I will share the PDF. Okay, my name is Komali. I am your chemistry mentor. Thank you so much for watching this video. You became just perfect in this elimination reactions bimolecular. In another video, I will come up with excellent concepts. Be ready. Please stay tuned to the Komali Mam channel. Thank you so much for watching.